students, welcome to mathematics class. I am Colin from the Department of Mathematics here at St. Philomena's PU College. In today's class, we will start with the chapter Sequences and Series. The name of the chapter is Sequences and Series. Sequences and Series. In your previous classes, you have already come across what an AP is. You have done problems on AP. In this chapter, we are going to study about AP. We are going to recall what an AP is. Then we are going to solve some more problems on AP. And also, we are going to study about another kind of sequence, that is a GP or a geometric progression. Okay. Now, coming back to sequences and series, you have come across many sequences. If I have the sequence, say 2, 4, 6, 8 and so on. Okay. Whenever I put 3 dots, what is the meaning of that? It means that the sequence has not stopped to the term at the term 8, right? Even after term 8, you have many terms. That means it is a continuous sequence. It is moving forward. But we have chosen not to write to denote that it continues or it has infinite terms. We have put 3 dots. So, this is an infinite sequence of numbers. Now, my question is this an AP? You have already studied AP, right? So, you can see, look at this sequence. Okay. The first term is 2. I will denote that by A1. Second term is 4, I will denote it by A2. Third term is 6, I will denote that by A3. And the fourth term, last term is A4, 8, I denote it by A4. Okay? And so on. There are many terms in this sequence. But second term minus first term, okay? 4 minus 2, what do we get? We are getting it as 2. 6 minus 4, what are we getting as? Again, we are getting it as 2. 8 minus 6, what are we getting as? We are again getting it as 2. So, you can see that the difference between any two consecutive terms of this sequence of numbers, we are getting it to be constant or we are getting it to be the same number. The number 2, we are getting it repeatedly. Hence, this sequence of numbers, we can call it to be an AP. So, what is an AP? An AP is a sequence of numbers wherein any two consecutive numbers you take, terms of the sequence you take, perform the difference, you get a constant difference, right? What is the meaning of consecutive terms? One after the other. One next to the other, first and the second term, or second and the third term, or third and the fourth term and so on, right? First and the third term won't be consecutive because there is the second term in between first and third term. Second and fourth term, you do not call those as consecutive terms because there is the third term in between, but first and second term, they are right next to each other, consecutive. So, what is the meaning of an AP? Any sequence of numbers wherein the difference between any two consecutive terms of the sequence is same. That same difference is called as the common difference, right? So, hence this sequence of numbers, you can call it as an AP. Okay. Moving further, let us take another example. Say I write 5, 10, 15, 20. Okay. So, I have written another sequence of numbers I have written 5, 10, 15, 20, and I have stopped there. I have not written 3 dots after 20. So what does that mean? I have not written 3 dots. So that means that the last term of this sequence of numbers is 20. So the sequence of number is stopping at the term 20, at the number 20. So what can we call such sequences of numbers as? Correct. We can call them as finite sequence of numbers. Finite means you can count the number of terms in the sequence, right? So this is the first term, second term, third term and fourth term. So there are 4 terms in this particular sequence. You can count the number of terms. Hence, we will call that as finite sequences. So this is a finite sequence. This is an infinite sequence, right? Because you cannot count the number of terms, that is why I have put 3 dots after 8, but here I have stopped till 20, denoting that it is a finite sequence. The last term is 20. Okay. Now, is this sequence of numbers an AP or not? It is an AP. Again, second term minus first term, we perform the difference between consecutive terms. Second term minus first term gives us 5. 10 minus 5 is 5. 15 minus 10, what do you get? Again, you get it as 5. 20 minus 15, again, you get it as 5. So you can see that there is a constant difference between any 2 consecutive terms of this sequence of numbers. Hence, we will call this sequence of numbers as an AP. Okay. Moving forward, sequences, I can generally denote it as, okay, if I can take the first term as A1, right, and we use commas in between any 2 terms, okay. First term, after the first term, I use a comma and I write the second term. Then again I use a comma and I write the third term. So I write it as A1, comma, A2, comma, A3, comma, so on. So the 3 dots represent that it is an infinite sequence. So any general sequence, we can write it to be A1, comma, A2, comma, A3, comma, so on. Okay. Now, we have denoted sequences like this. Also, we can denote sequences by a general term. Okay. So, how might it look like? Suppose I write AN equals, say, n square, where n equals 1, 2, 3 and so on. Okay. So this is, I am saying, the definition of a sequence of numbers. What is the definition or the general term? AN equals n square. Okay. Where what are n? What is n? N is nothing but any natural number. Now, to write the terms of the sequence, how is the general form of a sequence? We can take it as A1, A2, A3 and so on, right? Now, how do you find out A1? What is A1? Look at this, AN equals n square. So, when n equals 1, right, we can write A1. So, I am putting value of n equals 1. A1 equals 1 square. 1 square is nothing but equal to 1. So, the first term of this sequence is 1. Then, moving on. To find out second term, we put n equals 2. So, what do you get? A2 equals 2 square. What is 2 square equal to? It is equal to 4. A3, putting n equals 3. What do you get? 3 square. 3 square is 9 and so on. Since n is any natural number, and after 3 also there are numbers 4, 5, 6. So as usual, this sequence will also be an infinite sequence. So writing this sequence of numbers, I can write 1, 4, 9. Can anyone tell me the next term, the fourth term will be what? A4 will be nothing but 4 square. 4 square will be nothing but 16 and so on. So to denote that it is an infinite sequence of numbers, I just put 3 dots after 16. So this is, you can also denote a sequence of numbers by a general term, okay, or the nth term we call it. In a general way, we can define the sequence of numbers. Okay, moving forward, the next concept under this chapter is that of series. Series. So what is a series of numbers? Okay, to define a series, first of all we need to have a sequence of numbers. Okay, in general I will say let A1, comma A2, comma A3, comma A4, comma so on. Okay, this is an infinite sequence. It can also be a finite sequence also. Okay, I have taken a general sequence. Okay, sequence in a general form. In a general way, I have written it to be A1 denoting the first term, A2 which is the second term, A3, A4, comma so on. Okay, now the series associated with this sequence is nothing but the expression A1 plus A2 plus A3 plus A4 plus so on. Okay, just what have I done from here to here? I have replaced the commas with the plus sign, addition sign, right? We have taken a sequence of numbers in the general form. I have written it to be A1, comma A2, comma A3, comma A4, comma so on. Okay, instead of writing commas, I have replaced the commas with the plus sign. So we get A1 plus A2 plus A3 plus A4 plus so on. Okay, this expression is called the series associated with this particular sequence. So the definition of series of numbers, we might say it like this: a sequence of numbers, let A1, comma A2, comma A3, comma A4, comma so on be a sequence of numbers, then the expression A1 plus A2 plus A3 plus A4 plus so on, okay, is called the series associated with this particular sequence. Okay, this expression I can write it in sigma notation also. Okay, so this is equal to, I can write sigma A suffix k, right? Sigma A suffix k. Sigma denotes summation. Sigma denotes that I have to add, or I have to, there is a plus sign in between any two consecutive terms, and A suffix k is a general term of this series, right? When k takes the value 1, we get A1. K takes the value 2, we get A2. K takes the value 3, we get A3 and so on. So this is the notation, the sigma notation for this particular series. So this is as simple as that. For example, if I say, we'll take any example, say 1, 3, 5, 7. Okay, I have not written 3 dots after 7, which means that the last term of this sequence is 7. So, the sequence is stopping at number 7. Okay. So, this sequence has how many terms? 4 terms, 1, 2, 3 and 4. So, we have taken a sequence containing 4 terms. Okay. Now, I have to write the series associated with this sequence. So, what is the series associated with this sequence? Instead of commas, I just replace the commas by plus sign. So, the series will look like 1 plus, 3 plus, 5 plus, 7. Is that clear? I do not add this and write, but rather the same sequence I just replace the commas with the plus sign. So, this is the series associated with this sequence. So, whenever you have to define a series, you must first of all take a sequence of numbers, replace the commas with the plus sign. That expression is called the series associated with that particular sequence. Okay. Moving forward, we will solve some problems. So, problem number 1, write the first 5 terms, of each of the sequences whose nth term are, sub question 1 under this, a n equals n into n plus 2. Question number 2, a n is n by n plus 1. Question number 3, a n equals 2 power n. Question number 4, a n equals 2n minus 3 whole divided by 6. Fifth question, a n equals minus 1 whole power n minus 1 into 5 power n plus 1. And the last question, sixth question, a n equals n into n square plus 5 whole divided by 4. So, the question is telling us, write the first 5 terms of each of the sequences. What is given here? The nth term or the general term of the sequences are given. We have to find out the first 5 terms. The nth term a n is given here. We have to find out first 5 terms, a1, a2, a3, a4 and a5. We will do that now. Question number 1, okay. What is the nth term? It is very simple. A n is equal to n into n plus 2. N into n plus 2. We have to find out a1 up to a5. So, what is a1? I have to put in the place of n, I have to put 1. So, a1 is nothing but 1 into 1 plus 2. So, that is 1 into 1 plus 2 is 3. So, that is 1 into 3 equals 3. Very simple. A2, moving on, n equals 2. What happens? The same expression I have to put n equals 2. So, I get 2 into 2 plus 2, right? So 2 into 2 plus 2, 2 plus 2 is 4, 2 into 4 equals 8. Then A3, what is A3? 3 into 3 plus 2, which is nothing but 3 into 5, which is nothing but equal to 15. Fourth term, A4, all we are doing is we are putting in the place of n 1, 2, 3, 4 and finding out the answer. Okay, fourth term, 4 into 4 plus 2. 4 plus 2 is 6. This is 4 into 6. 6 4s are 24. Then fifth term, okay, we are putting n equals 5. 5 into 5 plus 2, which is nothing but 5 into 7. 7 5s are 35. So we have found out the first 5 terms of an equals n into n plus 2, 3, 8, 15, 24 and 35. Okay. Moving on. Problem number 2. An, it's given to be n by n plus 1. Okay. So what is A1? 1 by 1 plus 1, which is 1 by 2. A2 is 2 by 2 plus 1, which is equal to 2 by 3. A3 equals, you can pause the video and you can do it yourself, then you can play it again and see whether you got the same answers or not. Okay. A3 is 3 by 3 plus 1, which is equal to 3 by 4. A4 equals 4 by 4 plus 1 equals 4 by 5. Last term, well, the fifth term, 5 by 5 plus 1 equals 5 by 6. Yes. Moving on. Third question. Since these are simple problems, I am moving quickly. Okay. Third question, An equals 2 power n. Okay. What's A1? 2 power 1, which is nothing but 2. Second term is A2. A2 is 2 square, which is 4. Third term, A3, 2 cube equals 8. Again, for every problem, you can pause the video and you do it yourself, then play it again and see whether you have got the same answers. A4 equals 2 power 4, which is 16, and the fifth term, A5, 2 power 5, which is 32. Fourth problem. What is An? An equals 2n minus 3 whole divided by 6. 2n minus 3 whole divided by 6. Okay. What is A1? A1 is 2 into 1 minus 3 by 6. First, you substitute n equals 1 in A1 and then you simplify. Always remember, students, whenever you have the general term given to you, first you substitute for values of n. So, I have substituted for n as 1, 2 into 1 minus 3 by 6, and then only then I perform the simplification. So, now we will simplify. So, this is 2 minus 3 by 6, 2 minus 3 is minus 1, it is minus 1 by 6. Okay. Second term, A2. Remember, first substitution and then simplification. 2 into 2 minus 3 whole divided by 6, that is 4 minus 3 whole divided by 6. 4 minus 3 is 1 by 6. Third term, 2 into 3 minus 3 whole divided by 6. 2 3s are 6 minus 3 is 3 by 6. On further simplification, this is 1 by 2. I'll erase these, then we'll find out the fourth and the fifth terms. A4 is nothing but 2 into 4 minus 3 by 6. Now on simplification we get 2 4s are 8 minus 3 whole divided by 6, which is nothing but 8 minus 3 is 5 by 6. Then fifth term, the last term that we need to calculate, 2 into 5 whole divided by 6, 2 5s are 10, 10 minus 3 by 6, 10 minus 3 is 7 by 6. Okay. Moving on. Fifth problem, an equals minus 1 whole power n minus 1 into 5 power n plus 1. Same method. What is a1 equal to? First substitution, minus 1 whole power 1 minus 1 into 5 power 1 plus 1. So what is 1 minus 1? 0. So this is nothing but minus 1 whole power 0 into 5 power 1 plus 1 is nothing but 2, 5 square. We know that anything to the power 0 is equal to 1. So this is 1 into 5 square is nothing but 25. So the first term of this sequence is 25. Second term, A2, minus 1 whole power 2 minus 1 into 5 power n plus 1. So this is nothing but 2 minus 1 is 1, minus 1 power 1 is minus 1, 5 power. So this is 5 power 2 plus 1. 5 power 2 plus 1 is nothing but 5 cube. So what is value of 5 cube? It is nothing but 125. 125 into minus 1 is minus 125. Third term is nothing but what? Minus 1 whole power 3 minus 1 into 5 power 3 plus 1. So this is nothing but minus 1 whole power 3 minus 1 is 2 into 5 power 3 plus 1 is 4. So this is minus 1 whole square is plus 1, 5 power 4. So what is 5 power 4? 625. So this is 625. Next term, A4 is nothing but minus 1 whole power 4 minus 1 into 5 power 4 plus 1. Minus 1 power 4 minus 1 is nothing but minus 1 whole power 3. 5 power 4 plus 1 is 5 power 5. Minus 1 whole power 3 is nothing but minus 1, 5 power 5 we have to calculate that. So, this is minus 1, 5 power 5. 5 power 4 we know it to be 625. 625 into 5. I am doing it here. 5 5s are 25. 5 2s are 10, 12. 6 5s are 30, 31. So, that is 3125. So, that is minus 3125. Then the fifth term, A5, is nothing but minus 1 power 5 minus 1 into 5 power 5 plus 1. So, that is minus 1 whole power 5 minus 1 is minus 1 whole power 4 is plus 1. So, this is plus 1. 5 power 5 plus 1 is 5 power 6. So, 5 power 5 we know, 5 power 6 is 3125 into 5. Okay. 5 5s are 25, 5 2s are 10, 12, 5 1s are 5, 6, 3 5s are 15. That is 15,625. So, do not use the calculators, you work it out in the working column. Okay. Last question, question number 6. Question number 6, an is n into n square plus 5 by 4. Okay. What is a1? a1 is 1 into 1 square plus 5 by 4. So, this is nothing but 1 square plus 5 is 6 by 4. On simplification, this is 3 by 2. Second term, a2 is equal to 2 into 2 square plus 5 by 4. So, that is 2 into 2 square is 4, 4 plus 5 is 9 by 4. 2 1s are, 2 2s are, this is 9 by 2. Third term, a3 is 3 into 3 square plus 5 by 4. It is nothing but equal to 3 by 4. 3 square plus 5, 9 plus 5 is 14. 2 2s are 4, 2 7s are 14. So, 7 3s are 21. 21 by 2. Fourth term, a4 is nothing but 4 into 4 square plus 5 by 4. 4 and 4 cancels. We are left with 4 square is 16. 16 plus 5 is 21. The last term, fifth term, okay, that is 5 into 5 square plus 5 by 4. So, that is 5 square is 25, 25 plus 5 is 30. So, 5 into 30 by 4, 2 2s are 2 15s are 30. So, that is 5 into 15 is 75 by 2. Find the indicated terms. Find the indicated terms in each of the following sequences. In each of the following sequences. Question number 1, it's a sub question under this. an is given to be 4n minus 3. You have to find out the terms a17, that is the 17th term, and a24, which is the 24th term. Okay. All you have to do is just like the previous problem, substitute n equals 17 so that you get the 17th term, n equals 24 so that you get the 24th term. Then another problem, you try this, an equals minus 1 whole power n minus 1 into n cube. You have to find out the 9th term. Okay. One more problem, an equals n square by 2 power n. This is the nth term. You need to find out the 7th term. Okay. Work out these problems and we'll meet in the next class. Thank you.